Welcome to another fresh day, dear student. I am Ranjan Nayak, Assistant Professor in Mechanical Department at BIT. As you all know that I am continuing the chapter of gear ratio. Completed the simple gear according to the numerical certain I already get discussed, already get solved by means of size of the gear, by means of teeth, by means of RPM, and how to find out the torque. But now I am going to discuss about the simple gear train. That means when one or more number of gear will be arranged in a simple way, that means in a single line, okay, that is known as simple gear. Okay, in simple gear there is another type of concept come into the content, that is idle gear. Okay, here there is a driver gear. I already said that how many amount of gear get arranged in my previous video. Go to watch to that video, that how many amount of gear is required for the direction changing amount to get output with respect to the input. If you want the anti-clockwise with respect to the input, how many gear of arrangement is there, and if you get the same direction in the output with respect to the input, how many amount of the gear will be connected, or how many number of the gear is connected in the system. I already get discussed. Please go to that previous video to watch over it to get understand it. So A is the first is the driver gear, where the power is come into contact. The first power coming from the engine, the gear from the close left. That is where is the driver gear. It's the input part, input power come over here. Whereas C is a driven gear. Driven gear means output part. The output gear or output system, the power get output to the system. That means if you take this one is the system, this one is the input part A, and this one C is the output part. But from A to C, we can able to arrange another gear where the power can transmit very easily. That is B. The B is the adjacent number of gear, that is known as idler gear. Okay, idle gear means it is that medium in the between the A and C where the power get transmitted from the A to the C. That's why it is known as idle gear. Okay, it is not output gear. Okay, for this idle gear, the rotation of this output gear is changed, because here it is a clockwise direction clockwise direction of rotation. But if you go for the idle gear over here, it moves anti-clockwise direction. Okay, if you move anti-clockwise direction, so if you get the output gear at that time, we are getting the anti-clockwise. For this anti-clockwise same direction means the gear A is one direction, the clockwise direction. The same direction if you are going to getting in the C, for the purpose of that we are going to use this idler gear. Okay, if you do not use this idle gear, then means A and C is connected directly. That is simple gear that I already discussed. Okay, now we all know about this gear ratio, that is R is equal to N1. N1 means input, that is driver speed by driven speed. T2 by T1, that is size or number of teeth of driven part to that or output part to that of input part of the driver part or driver gear. Torque 1 means torque input. This torque 1 is a torque input, R is a gear ratio, and torque 2 is the output. How to get over it? And this one is important over here. Okay, this thing is very important of this type of simple gear train. That is that if you take how to get the output speed or output gear by means of this what? First take A and B. Okay, fast power get transmit from A to B. So this one is A, B. In AB, B is output. Always in AB, with the A and B, the last part is the output. Okay, in AB, A is input, B is output. Okay, so your B is output and A is input. Similarly, from B to C, now B become input and C become output. In the BC combination, B is input and C is output. So in total combination from A to C, A is input and C is output. This is a general concept before going to get solve the problem. Okay, now we are going to solve one simple problem over here. So let's take very simple numerical simple data to understand about it, how it is working, how to get it. Suppose for example, if you take in gear ratio, first of all find out this gear ratio. Suppose this N1 speed or the speed of the N1 or teeth, number of teeth. Here the three gear have same teeth. Just look over here, the three gear is having same teeth. Same teeth means what? The size of the three gear is same. If the size of three gear is same, that means what? The gear ratio is 1. That means the gear ratio will be 1. How it is become 1? just look over here, this gear ratio GR, okay, this gear ratio or R, that is equal to T2 by T1, okay, T2 by T1. So if you get T2 by T1, take T2 means what? Suppose take for the condition of this condition A and B, for the condition of A and B condition, so B is output. So if B is output means let take T2, let this T2 is 10 number of teeth. Okay, that means A, B, C, that is equal to 10 number of teeth, or 10 number of teeth is there because size is same. Size is same. If size is same, that means 10 T2 by T1. T1 means 10. Okay, that means T2 over here, what happened? T2 is equal to T1. It is equal to 10 teeth. Okay, that is equal to 10 teeth. Next, this gear ratio is equal to 1. So this A and B gear ratio become 1. Similarly, if you go for gear ratio of B and C, it will also become 1. It also become 1 because teeth is equal. So if you go the gear ratio from A to C directly, if you go from gear ratio A to C directly, A to C, that means also it will be 1. So the gear ratio R is equal to 1 in this problem. In my before problem, I already discussed by changing the gear size in the simple gear. Now it is the first problem in simple gear train where the gear size is same, the size is same. Okay, if size is same, then what happened? Let's take, you know that R is equal to the N1 by N2. Okay, so R is 1. So R is 1 means N1 by N2, that means N1 is equal to N2. That means N1 is equal to N2. Okay, N2. If you take R N1, N2 means if you take anything from A to B, same condition will be there from 1 to 2. Similarly, R, or if you take A to B, or if you take B to C, or you will take A to C directly, you will get one relation, N1 always is equal to N2. That means what? This N1 is equal to N2. That means what? The speed of A, B, C is equal. Okay, the speed of A, B, C is equal. If all are equal, so what is this torque? This torque 1, that is input, anything, if you take a B, BC, C or AC directly, this torque 1 is equal to R is 1. R is 1 means 1 into torque 2. Okay, torque 2, that means torque 1 is equal to torque 2. Torque 1 is equal to torque 2. Okay, that means what happened over here, just look it off. This is one relation. This is one relation you will getting. Another over here, you are getting this one. This one is given data. Okay, that means everyone is equal over here. Teeth is equal. That means only one variable, that is if the size of the gear, what is the physical consequence or what is the physical idea about it? What will happen physically if this gear system will be incorporated in the automobile? Okay, what happened if the teeth means the size of gear? That's why that's why I will solve this problem. That's why I'm going this problem I solve for the purpose is that if the size of the gear is equal, then what will be happen? It will incorporate in the automobile. So what will happen? If teeth size is equal, the speed will be equal. The speed will be equal. Speed equal means the input speed always equal to the output speed. Same thing. Another things what happen? Torque will be equal. The power transmitted or to the input is equal to the power in the output. That means whenever we will require same amount of output with respect to input, or input is equal to output, we not get any type of variance or less or higher or half or double. Okay, at that time we are going to use this type of arrangement. That means when there is the size of the gear or teeth size is equal, at that time everything is equal, the speed will get output is equal to input, the torque, the power will get in the output is equal to that of input. The next problem, the same formula, we are going to the next problem. In the next problem, the same simple train or simple gear train, but this one having different type of teeth. Okay, this one having different type of teeth. So how to find out? Okay, this one having a different type of speed, but remember one thing, this A will be input, this A is input, C is the output, whereas this B is the idler. Okay, so our fundamental is we have to find the question that we have to find out AC condition. Okay, we have to find the AC condition over here. We have to find the AC condition, means A is input and C is output. This is our fundamental thing to find. In A and C, where this A is completely input, input means is the drive part, and C is the output. Okay, this condition, for this condition we are going to getting, means A is the input and we are getting the output at the C. This one is a driver. Okay, this one is a driver part, this one is a driver, this one is a idler, and this one is a driven. This one is a driven. Okay, so what will be the rotation? Rotation means if you take this A will be rotate in clockwise direction, then this B will be rotate in anti-clockwise direction, then C will rotate in the clockwise direction, because they are odd number. Okay, now we are going to find, to getting the AC, same thing will be happen, same thing will be repeat. That means we have to find, first case we have to find AB, we have to take AB condition, and in second case we have to find, that is BC condition. Okay, after these two condition fulfilled, we will getting this AC, what will the result come into contact. So let's take, because these are three different size of the gear, so this one is very small, this one is medium, this one is large. So taking very simple example or number for that, suppose let's take this one is 10, okay, this one is 20, and this one is 40. Okay, suppose let's take teeth, that is A. Okay, number of teeth of A. Okay, number of teeth. Okay, number of teeth. Okay, that is A gear. A gear, that is, if you're going to write TA, let's write TA, let's take 10. Okay, okay, I am not repeating the same thing, I am just writing the value next. Similarly, the number of teeth of TB, let's take the number of teeth of TB. TB means number of teeth of this B idle gear. Let's take just double of it, that is 20 teeth. Okay, and after that let's take TC. TC means what? TC is a driven or output gear. This one is bigger in the size, so let's take this one is 20 teeth, 10 teeth, 20 teeth, and this one is suppose 40 teeth. Okay, over. So now if you are getting these three size of the gear, then we are going to getting the gear ratio. First, the gear ratio will getting from first condition AB. Go for first condition AB. Okay, in first condition AB, first case AB, the gear ratio 1. Okay, gear ratio 1 means you will only take the A number and B number. If B is output, so TB by TA, output by input gear, driven by drive. So this is a reason, that is TA, TB by TA. So TB is what? Output gear, B is output and A is input. So TB is 20 teeth of B, and number of teeth of A is 10 teeth. So that means what? It's going to get 2 teeth. 0, 0 cancel, 2. Ratio become 1. So GR1 or gear ratio first case, AB if you will take, that means in the first case, AB if you are going to taking, then the gear ratio first we obtain 2. For which purpose? AB, okay. Secondly, the same thing will be happen for the BC condition, okay. From the BC condition. From the BC condition, let's take the gear ratio 2. That means C is output. Now in BC condition, C is output and B is input. So output by input, teeth number, so TC by TB. So TC is what? TC is 40 and TB is 20. So it is also going to get 2, okay. Also going to get 2 teeth, okay. So gear ratio 1, 10, then double 20 and double 40. The gear ratio become 2. Same gear. Now if according to our example that we are taking 10, 20 and 40 teeth, this gear ratio become 2 over here, okay, 2. So if we are going to get another, that is for example, in the third case, if we are going to get A and C, directly AC gear ratio, what we will get, okay. In the third part, C is output, A is input, C is how much? 40 teeth, that is TC by TA, and TC is how much? 40, and TA is how much? 10. Now it become 4, okay. So this one, in first case gear ratio is AB, if you will take gear ratio 2, in second case gear ratio become 2, in third case in the gear ratio become 4, okay. Why we are going to find this gear ratio in different prospects? In different prospect we are going to get gear ratio because if any speed is given of any number of in any gear, then we are going to find the speed of another gear very easily. Now for example, let's take अब speed है तो क्या होगा, देखो यहाँ पे मतलब what happened if this is a small gear, okay, the way it will rotate, okay, it will rotate faster than this gear slower and this is another slow, okay. If the gear is very large, it will run very slow. Gear is very small, it will rotate very fast because the circumference, the size of teeth is very small. So according to that concept, let's take this NA, the speed of this, maybe take the highest number of speed that I'm going to get, take over here, make 100 RPM. Okay, let's take NA is 100 RPM. Okay, so then if NA is 100 RPM, then how we are going to getting this B value and C value? That means how we are going to get this NB speed, NB and this NC speed? How to get? By means of gear ratio formula, okay, by means of gear ratio formula, okay. Directly put, if you find NB, that take the gear ratio, NB means you have to find this speed or this B gear idle gear speed. So AB, take this AB, the first gear ratio AB is how much? Is 2. So directly write down the gear ratio 2, that you know that the formula is, if there is a speed in AB condition, if there is a speed, then it will be the first gear speed by second gear speed, that is NA by NB. NA by NB. So NA is what? NA is 100. So you are going to find NB. So NB become, so what happened? NB become 50. Okay, NB become 50 RPM. Similarly, if NB become 50 RPM, then what happened for NC? In NC, for NC value, you have to go for BC value. Gear ratio is 2. If gear ratio is 2, you are getting B and C, input this one, output this one, that with NB by NC. Already know this formula. NB we are getting 50 RPM. Now we are going to see NC, that is NC is 25 RPM. Okay, in the similar way we are going to getting the speed. In same way, you are also going to get the torque. Okay. In the same way, we are also going to getting the torque value. Okay. The torque value. Let's take the torque value for torque 1, torque 2, torque 3. Okay. The larger gear will be produce more torque. The smaller gear then required lesser torque. और सबसे छोटा वाला gear, the smaller gear containing number of torque is less, means because if the gear is very large, okay, the speed is less, torque is more. Okay, speed is less, torque will be more. So let's take the torque of this C. Okay, let's take the torque of this C value. Okay, so before that I will be not omit. Okay, it will be continue. Okay, before that I'll going to just write over here. Let's take the value of torque. Let's take another suppose torque from the value C. Okay, let's take from torque value C 200 Newton meter. So we will going to find out the value of torque B and value of torque A. So how to find out value of B and value of B? Then we will getting the value from the point B and C. The gear ratio is 2. Okay. So what is the formula? Output. Okay. Not in output is equal to R into input. That means in B and C, what is output? Output is C. Okay. Output is C. That means torque C is equal to gear ratio of BC. Gear ratio of BC is 2 is equal to input. Input means what? Input is gear B. Okay. That means torque. Here the value of torque of B. So we have to find the value of torque B. The C torque is also given, that is 200 Newton meter divided by 2 is equal to torque B. So the torque B value is equal to 100 Newton meter. Okay. Similarly, how to find the value of torque A? How to find the value of torque A? The value of torque A, if you find, then if you will take the value of torque B is equal to R into the value of torque A. From where? From the ratio of AB. In AB ratio, the gear ratio is also 2. So value of torque B is how much? 100 Newton meter. So 100 Newton meter, R is equal to 2, that is divided by 2. This R will come just below it, that is 2 value is equal to torque A. So torque A value is equal to 50 Newton meter. 50 Newton meter. So what is happening? The torque C is 200 Newton meter, whereas torque B is 100 Newton meter, and this torque A, the torque A is 50 Newton meter. So just see over here, if the gear is larger, the C is larger gear, so 200 Newton meter speed or torque. What is the speed over here? 25 Newton meter. That means when the speed is less, NC value, that means the speed of this gear is very less because the size of gear is very large. But the power transmit by this output gear is more, torque is more, 200 Newton meter. Just go for backside, that is B gear. The size of B gear is smaller than C gear, so the speed is increases from 25 to 50 RPM. Similarly, in this B gear, the torque or power will be reduced from the C as 100 Newton meter. At the simultaneously what happened at the gear A, the value of speed is 100 RPM. Okay, 100, that is highest speed over here, 100 RPM. So the torque will be very lower, that is 50 Newton meter. The torque is higher, speed is less, speed is higher, torque is less. So this is all about how to find out the speed, the torque, accordingly the size of the gear, the problem of the simple gear train with different type of teeth and the simple teeth. Okay, and the same number of teeth. In the next class, I will discuss about this compound gear train. Okay, this problem I will discuss in the next class, compound gear train, how to find out in the compound gear train class. So up to here, stay tuned for my next video. Thank you very much.